So you heard about double reprocessing, and probably about 50% of the centers do this. We actually are not doing the double reprocessing, but we're taking other measures to address the contamination that we can discuss later on. But this is a great study that Doug Rex did at Indiana University. So he cultured 592 duodenoscopes that had undergone double reprocessing, right? So you do the high-level disinfection twice. And what they found was that the contamination rate was almost the same as what was reported in the post-market survey that the FDA conducted, 9.4%. So then they made a change. And the change that they made, and I think this is an important change to take note of, is that they changed the pre-cleaning solution. So they paid more attention to the manual cleaning and which pre-cleaning solution they used. So previously, they were using an enzymatic solution. And then what they changed is they went to a non-enzymatic solution, a detergent solution, and it's called Intercept. And it is now considered currently, I absolutely have no conflict here with that product, but that product is at this time thought to be the ideal solution for pre-cleaning. And most importantly, it's because of the studies that address biofilm that this penetrates more aggressively into the biofilm. So we'll hear more about that, but just remember that term biofilm because it's important. All endoscopists who do ERCP are familiar with biofilm because that's why our stents clog. So they did a phase 3 part of this study where they also did spot audit checks of the cleaning personnel, so intensifying the Hawthorne effect, and there was really no difference. So the bottom line here is even if you do double reprocessing and you use the best pre-cleaning solution that's out there, you still cannot eliminate contamination. You still have a 5% contamination rate, and that's just not acceptable. So why is it that this is so difficult to eradicate, this contamination? So this is another Dutch study that looked at the root causes of contributing factors. So you heard a little bit about this, and obviously the elevator is one of the culprits, but it's not the only culprit. So they looked at damage and deposits around the lever axes, the forceps elevator, the elevator screws, and they found that they were unable to reach many of the deposits with their brushes and that they were poorly accessible for rinsing or drying. So in this upper panel here, you can see the elevator. So that's sort of obvious, right? The irregular surfaces here, the nooks and crannies everywhere that are just so hard to clean. And it would be wonderful if it were just an elevator problem, because maybe the solution would just be a disposable elevator, but it's not. So they pass these borescopes, you can see it here, through the endoscope working channel. And when you look into the working channel, that's where you see where I think the real problem is, aside from the elevator, and that is all the cracks, the fraying, the disintegration of the lining that occurs over repeat uses. It really looks like a war zone when you look inside of the working channel. So next time you pass your spyglass probe through your duodenoscope, take time and look at the lining of the working channel. I did, and it is really quite daunting. So the problem here in the working channel, apart from the fact that you can't get there, right? You can pass your brushes through there, but you're doing very little, is that we're dealing with biofilm accumulation in the working channel. And This biofilm, you can see a cartoon of it here on the left side, complex mushroom-shaped architecture. Looks like, you know, something from deep sea diving or so, with these streamers. And what are formed are these water channels. And the bacteria, they attach, they become, they are adherent, irreversibly adherent to this biofilm. And the fluid that is running through this, it penetrates deep within the biofilm, and it actually carries the oxygen and nutrients for the bacteria. So the bacteria love the biofilm. They flourish there. That is their home. And you can see what that biofilm looks like on this electron microscopic image. I think this is fascinating, and I think this is the problem. I've known about this for a few decades because I've been working on many different plastic stent designs to address the issue of biofilm accumulation. And I've been humbled each time at how difficult it is to eradicate biofilm. It's really been impossible, right? We tried silver nitrate coating, we tried antibiotic coating, we tried all types of different types of polymers, etc., to address this, and we have not been successful. If we had been successful, we would not have expandable metal stents today. So that is proof that we never conquered the biofilm dilemma.